Hello. In this video, we want to look at an application. A company selling computers finds the cost per computer decreases linearly with the number sold monthly, decreasing from $1,000 when none are sold to $800 when 1,000 are sold. Thus, the average cost function has a y-intercept of 1,000 and a slope of -200 over 1,000 because it went down $200 when 1,000 were sold. So negative 200 over 1,000 simplifies to -0.2. So it's given by the formula C bar of x equals 1,000 minus 0.2x. And then these limits are, first of all, you can't sell less than 0, so that's a limit there. The upper limit here, 1,000, is where this is equal to 0. So those are the two limits, where x is the number of computers sold monthly. Since C bar of x is just the cost function divided by x, if we want to get the cost function back, we just multiply the average cost by x. So it's going to give us x times 1,000 minus 0.2x. Good. Now, if you distribute that, that gives you C of x equals 1,000x minus 0.2x squared with the same limits. Now, if we suppose that the revenue function can be approximated by R of x equals 0.0008 x cubed, minus 2.4x squared plus 2,400x, where 0 is less than or equal to x is less than or equal to 1,000. And then we want to determine any intervals on which the profit function is increasing. Okay, so here we really only have a few different things that we need to look at. First of all, notice that your cost function is listed here, and your revenue function is listed here. Those are your cost and revenue functions. Now we're wanting to know when is the profit function increasing. Okay, so remember that the profit function itself is just the revenue minus the cost. So this would just be 0.0008x cubed minus 2.4x squared plus 2,400x. And then we're going to subtract off the entire cost function of 1,000x minus 0.2x squared. Distribute the 1,000. That's going to give us distribute the negative. That gives us 0.0008x cubed minus 2.4x squared plus 2,400x, and then minus 1,000x plus 0.2x squared. Awesome. And then we want to combine like terms. Notice that the negative 2.4x squared and the positive 0.2x squared combine. And then we also have, so we have that combining over there. And then this one, the 2,400x and the negative 1,000x will combine as well. So this is going to give us 0.0008x cubed. And then negative 2.4 plus 0.2 is negative 2.2x squared. And then the 2,400 minus the 1,000 is positive 1,400, and then the x there. So there you go. This is the profit function. But notice that we want to know when is this profit function increasing, which means we need to find the derivative, because the derivative can tell us where the profit function is increasing. So to do that, we need to find p prime of x. Well, this is actually pretty easy. It's a polynomial. Bring the 3 down in front. So 0.0024x squared minus, bring the 2 down in front. 2 times 2.2 is 4.4x, and then plus 1,400x. Wonderful. Now, at this point, we just need to find the critical numbers. To find the critical numbers, that occurs wherever the profit function's derivative is equal to 0. So 0.0024x squared minus 4.4x plus 1,400, there's no x there, is equal to 0. Wonderful. And then just find the solution. Now, my recommendation is to use the quadratic formula. If you have the quadratic formula function on your calculator, I would recommend you use it. But if you don't, remember here A is 0.0024, B is negative 4.4, and C is 1400. And so the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. There we go. So negative b means the opposite of b, so it makes that positive 4.4. And then plus or minus the square root of, and this is going to be kind of long here, negative 4.4 in parentheses squared. Be careful to make sure that's in parentheses, or just leave off the negative, one of the two. Minus 4 times a, which is 0.0024. 0024, yes. Times c, which is 1400. And then all over 2 times a, and a is 0.0024, so this would be 0.0048. Now, if you type this into the calculator, and you should do this right now, but I've already done it, and that gives us, rounded to the nearest decimal, is 409.8 for the minus, and for the plus, it was 1423.6. Awesome. Well, here's the thing. A lot of people at this point would just say, well, we can use both, but we can't. We actually have to reject that 1423.6 because if you go back up here, notice that the limits are actually between 0 and 1,000. So for this profit function, 0 is less than or equal to x is less than or equal to 1,000. That's the only realm in which this is accurate. Therefore, we have to reject this 1423.6. Good. Now what this means is that we only have one critical number here in the region between 0 and 1,000. So what do we do with it? Well, we use a number line, and we're breaking this up at 409.8. We need a number to the left and a number to the right. So x and then p prime of x. Now, if you plug this into the calculator, any number to the left of 409.8, might as well just use 0. And if you do that, p prime of x, all that's 0 over here, and we're left with 1400, that's positive. So if you choose 0, we're going to get a positive out of it. And now to the right of 409.8, if you choose, say, 1,000, this is going to become negative. Well, actually, it's 0. It's not really. Okay, all of this will become negative when you plug in 1,000. So let's say 1,000 over here. And that'll give you a negative there. Good. So, where is this function increasing? Where is the profit function increasing? Well, the profit is increasing on 0 to 409.8. Now, in terms of this question, 409.8 doesn't really make any sense because x is the number of units that are produced and sold. So 409.8 doesn't really mean much to us, so we're going to have to say 410. We're just going to go ahead and round that to the nearest whole number. So it is, the profit increases between 0 units and 410 units. So there you go. Alrighty. And here's everything I did for this video. I'm going to go ahead and end it here. Now we'll see you in the next one. Have fun.